In this video, we'll be talking about fractional distillation. This is a method, a process used to separate miscible liquids by evaporation and condensation. This is done repeatedly, unlike simple distillation. And then it also uses a fractionating column. I will show you a diagram soon, and then I'll explain using the diagram. So the mixture, two or more liquids are miscible, are separated by this method into their component parts. It is important to note that fractional distillation uses boiling point. Separation is done according to boiling point. So even if the liquids have close boiling point, unlike simple distillation, fractional distillation would also be can also be used rather to separate them into their various fractions. And this is the setup that is used to carry out fractional distillation. This is the flask where the mixture is placed and then heated. This is the fractionating column. Then this is a thermometer attached to the column, and then this is a condenser. The essence is to condense the vapor that passes through it and then collected, as the case may be. So when the mixture is heated and the temperature increases gradually until the whole mixture begins to boil, but the temperature of the fractionating column doesn't increase to the same extent as the temperature of the mixture in the flask. It increases more slowly, and then along the line at some point it attains the temperature of the fraction here with the lowest boiling point. For example, if the mixture is let's say ethanol and water, for example, there may be more than two, and the mixture is boiled, the temperature of the fractionating column will increase until it attains the boiling point of the ethanol, which appears, or which is the fraction with the lowest boiling point. When that happens, only the vapor of ethanol will pass through, because the temperature of the fractionating column is lower than the boiling point of water. The vapor of water, for example, will condense and go back to the flask. So only the ethanol will pass through, and then it is condensed and collected. The temperature of the fractionating column increases progressively until it reaches the temperature of the boiling point of water, which happens to be 100 degrees Celsius. So when that happens, the vapor of water can pass through and can be condensed and collected. So that's how the fractionating column works. That's why it is described as repeated evaporation and condensation. It's the same principle that is applied in the oil industry to separate the various fractions of petroleum. However, the scale is at industrial scale. This is a laboratory scale. Also, separation can be done using chromatography. Chromatography is usually used to separate complex mixtures like ink, pigments, etc. It uses a solvent, which happens to be a moving phase, and then over an adsorbent medium. Depending on the type of chromatography, it could be a filter paper, a chromatographic paper, or a gel, or any other thing for that matter, depending on the type of chromatography. Um, there are different types of chromatography actually. There's paper chromatography, and then column chromatography, and thin layer chromatography. There's also gas chromatography as well. So, but for the sake of this class, we're focusing majorly on paper chromatography. So remember I said there is the moving phase and then the stationary phase, or what we call the adsorbent medium. So this is how it is done in the thin layer or paper chromatography. Um, the the substance to be separated, such as ink, is placed on this pot, and then the solvent, which happens to be the moving phase, it is placed inside the solvent as shown. The solvent rises on the paper by capillary action, just as kerosene would rise through a wick, and then or candle will rise up the thread and it burns. So it's the same action that occurs through capillary action. As the solvent is rising, it dissolves the mixture here. However, it doesn't dissolve the component of the mixture to the same extent because they are made up of different materials. Different materials will dissolve to different extents. Another factor that is at play here is the adsorption to the paper. Because the mixture is made up of different material, they don't adhere to the same degree on the paper. Some adhere more than the other. So two forces are actually at play here. The forces of adsorption or adhering, and then the forces of dissolution in the solvent that is rising of this paper by capillary action. So the materials that adhere more and are least soluble would not easily dissolve in the solvent as it rises up. But the ones that adhere less and are more soluble will easily dissolve, and the solvent will carry them up the paper. So as such, when the paper is removed, they will stick back to the paper and then in various positions as shown, will be separated across various distances as shown. This can also, method of chromatography can be used to identify a substance, or yes, the type of substance in a mixture. And then one method we use to do that is a concept we call the retention factor, or RF. It is calculated by the distance traveled by the substance over the distance traveled by the solvent. So as the solvent travels, um, it will move ahead of all the substance. However, it also carries each fraction of the mixture across the paper. So there is a solvent front shown by this line, and then there is the point where each mixture, each component of the mixture is separated. So the retention factor is the ratio between the distance traveled by a particular component divided by the distance traveled by the solvent front. So every substance has a constant retention factor, and it can be used to identify them in various mixture. Another separation technique is flotation. As the name implies, is a method used to separate substances that has wide difference in densities of the component. For example, if there is a mixture of sawdust and iron filings, for example, the sawdust has a much lower density than the iron filing. As such, if it is poured in water, the sawdust will float, but the iron filings will sink. As such, the sawdust layer can be decanted, which happens to be the lighter layer, and then both of them will be separated. But in using flotation to separate a mixture of substances, first, neither of the solid must dissolve in the liquid that is introduced in the case of the water I used. So if any of the solid dissolves, then you are no longer using flotation. So flotation is used um, when the liquid doesn't dissolve any of the solid.